We are Group 7, Raphael, Bryan, Harreynish, and Klaus in ME110 Section 3 at SJSU. We are presenting a 2.5-gallon steel pressure pot from California Air Tools. For those who don't know what a pressure pot is, it's a chamber that receives air from a compressor, and for this one it withstands a maximum of 80 psi and operates at 60 psi. Often, this pot is used for casting resin projects. It involves 19 unique parts, and none are really moving. There is an inlet valve, elbow connector, hex Cooper sleeve, pressure regulator, ball valve, pin cotter, welded brackets, washers, butterfly nuts, and others. Now, how could this pot have been made? We'll start with what we know, its surface finish.
The inside of the pot is coated with Teflon as a surface finish. Teflon coating, or polytetrafluoroethylene, is a type of coating that is used because of its immense advantages. Teflon coating remains unaffected by temperatures as high as 500 degrees Fahrenheit. It also has powerful nonstick properties, doesn't react with chemicals, and is an electrical insulator. Teflon also boasts long-term performance. Because of these advantages, Teflon is used universally as a non-stick coating in cooking applications.
What about the main body? We know that it's made out of steel, but how is it made?
The main shape of the pot is most likely stamped from steel sheet metal in a process called drawing. Drawing would be used here for its high production rates, stronger parts, and there being less chance of defects. Another method would be die casting, but even though it could be possible to die cast a cylinder, it seems needlessly complex and expensive as the pot shape is not all that complex itself. On some parts of the assembly, there seem to be parts that have been welded on. It seems resistance welding or projection welding is most likely as the weld seems to be concentrated on one spot at a time with little deformation. The advantages are there is no filler metal needed, low cost, and low manufacturing time. An alternative method could be friction welding, but it seems inefficient to rub so many parts and threads one by one.
Considering that we went over the main body, what about the feet of the pressure pot?
The four rubber feet attached at the bottom of the pressure pot are manufactured using compression molding. Compression molding is used here because it is easy to use and it is cost effective for short production runs. It has low tooling costs and offers medium production rates as well. An alternative method to manufacture the rubber feet is extrusion. The plastic parts on the pressure pot, such as the handle and the cap of the safety valve, are manufactured using injection molding. Injection molding is used here because it has very high production rates, it has low cost to manufacture each part, and it is good for complex shapes.